All right, folks, 3:15, so let's get started. Thanks a lot for attending today's session. My name is Yavor Georgiev, and I'm a program manager working on Silverlight. Today we're here to talk about what's new in networking and web services in Silverlight 4. You all heard in Scott's keynote this morning that Silverlight 4 beta is available right away. So all the features I'm going to cover, you can go and play with it in the beta. It's all right there for you. All right, so let's get going. As you move your application from the desktop and then into the browser, getting data into the application itself quickly becomes one of the big challenges and one of the most important problems you have to tackle. And so Silverlight has a variety of networking and web service solutions that make it a very powerful and flexible platform. But sometimes that flexibility can get in your way. Sometimes it's actually hard to decide what technology to use for what scenario. We have System.net, we have WCF, we have WCF data services, WCF RIA services. So sometimes it's hard to think about the space. One of the goals of today's talk is to provide you with a mental model, sort of a map that you can use to navigate the space and decide what to use when. And to do that, I've put up this diagram. I have two pivots. In blue, you see the message pattern. And on your left, we start with a request-reply message pattern. In this pattern, every communication is initiated by the Silverlight client. And this should be familiar to you. This is exactly how HTTP works. Moving along, we have a duplex message pattern in which either the service or the client can initiate that communication. And this is compelling in scenarios such as a chat server or building an email client where the server needs to let the client know, hey, you've got new email. All the way on the right, you see a multicast message pattern, which is a massively scalable pattern in which you give the message to the underlying network devices, and they distribute the message for you. The server effectively sends just one copy, and the network does the distribution. The other pivot is the interaction model. On your right, we start with the operation-centered interaction model. And in that case, you can think of the service and the client as being objects in memory that have operations that they can call on each other. They're passing messages. And they have some in-memory state that is being modified by calling these operations. Moving along to the other pattern, we have the resource-centric pattern. In this pattern, you start with the data. You start with a database or some data model that's constrained. These data models usually have only 4 operations. You can create something, read something, update it, or delete it, right? That's called CRUD. And so in this resource-centric pattern, using these 4 operations, your logic is fairly thin. And so your application is effectively just a view on top of that data. And the data is being modified through these 4 simple operations. An example here is just any REST service, right? Working with a REST service. An example for the operation-centric pattern is something like a chat server, something that sends messages back and forth. So what we're going to try to do is map technologies to this spectrum here so you can know what technology to use when. And I know this is a bit theoretical, so let's dive through some of these scenarios which we're going to cover today in detail. We're starting with the forms over data application that you're all familiar with. When we move along, we have something like accessing a public REST service. Further on, we have a scenario where you own the data, so you build your own REST service on top of a data model, and then you access that from Silverlight. Beyond that, we have kind of the canonical SOA app. We have an app which accesses server business logic over a protocol such as such as SOAP. Moving along, we have a chat application, and at the bottom, we have an application that streams video or some kind of data across your entire enterprise. So these are the scenarios we're going to cover today. Now, before we dive in, I should say that I assume you're familiar with technologies such as WCF or WCF RIA services, data services, or just the classes in the System.net namespace. If you've never heard of these before, and there's another session you'd like to catch right now, that might be a better use of your time. Don't worry, I won't be offended if you leave. I just want to make sure you make the best out of your time here at PDC. So with that, let's get started. Going with that diagram, here's where the forms over data scenario lives. It's a resource-centric type scenario with request-reply messaging. The technology of choice for this scenario is what we're now calling WCF RIA services. It's the recommended technology for forms over data. It gives you a prescriptive model. So it gives you a model how to build your service that speaks these 4 CRUD operations that the resource understands. So it gives you a shape for your service, and it also gives you controls that also understand these 4 operations. So end to end, you get this prescription. You get this model about exactly how to build the application. Beyond that, we have great tooling. So we abstract away the fact that the client and the server are talking to each other over a network connection. So you just think about the fact that you're building an end-to-end app. You don't necessarily worry about the fact that there's a network in between. That's a nice productivity feature. At the end, it's all about data. So we provide things like filtering, sorting, paging, and validation. So for example, you configure validation rules once on your data model, and then that gets propagated all the way into your UI controls. And you saw that in today's demo. What we announced today is that RIA Services is now built on top of WCF. WCF is a very powerful messaging framework. However, it can be a little bit daunting if all you're trying to build is a forms over data application. RIA Services gives you a very simple and productive pattern to do that forms over data application. And it hides away the complexity of WCF. Now, WCF is still under the covers, so it's still there for you in case you want to tweak one setting, you want to make some more advanced change. What we're talking about in this talk, however, is not RIA Services. The RIA Services talk, we have actually 2 of them tomorrow that are going to go and you're going to learn basically all the details you ever wanted to know. But today what we're going to focus on is all the other scenarios that are not forms over data. Looking back at this diagram, this is the part of the space that RIA Services addresses. The question we're trying to answer today is, what do we do for the rest of this spectrum? What technologies do we use? And to convince you that this is a space worth looking at, let's jump into a quick demo. What I've built here is a travel agent application. So this is something that a travel agent might use day to day in the office. Right here at the top, it displays flight prices. And this is currently static content. It doesn't actually do anything. But you can imagine this being live data up here. Then, as a travel agent selects a given flight, we pull down contextual information here about that flight. Where it's going to, where it's coming from, whether it's on time. On the right, we have sort of productivity features. There's a chat feature, so different travel agents can talk to each other. And there's a list of tasks, so the travel agents can collaborate on a project. Just a couple of minutes from now, we're going to start taking this application apart and seeing how we built each piece. We covered RIA Services and the forms over data scenario. Now let's talk about what other scenarios fit in that resource-centric request-reply square. We have the canonical accessing a REST service, accessing any public REST service. That's a canonical scenario for resource-centric apps. Another scenario is again related to REST, but this time you own the service. This time you own the data model and you built your own REST service that you're now accessing from Silverlight. So that's the distinction. Do you own the service or not? So let's dive into that first scenario, accessing a public REST service. Silverlight 3 and Silverlight 4 offer a great new client HTTP stack. This HTTP stack is based directly on top of the operating system networking capability, not on top of the browser. The stack that's available in Silverlight 2, which is called the browser HTTP stack, that stack builds on top of the browser. So one stack's on top of the browser, one's on top of the OS. And because of that, there's some functionality differences between the 2 stacks. Most of the functionality is exactly the same, but there are some important differences. So let's talk about why would you choose the client HTTP stack. Well, the client HTTP stack gives you great support for accessing REST services. It supports the full set of HTTP verbs. It also gives you access to the response body regardless of the HTTP status code. It also gives you more fine-grained control over things like cookies and authentication. And I've tried to summarize all the differences in this one table here. On the left, we see the browser stack. On the right, we see the client stack. If we first focus at the bottom of the table, we see those REST features I mentioned. So HTTP verbs, better support for request and response headers, response bodies, status codes. All these features help you effectively work with a REST service. Now, the client HTTP stack has changed between Silverlight 3 and Silverlight 4. So in Silverlight 4, it has some new features. Especially, you'll notice around authentication, we now support basic, digest, and NTLM authentication from within the client HTTP stack. Another new thing you will notice is around cross-domain support. You're all familiar with this. Cross-domain files are something that a service owner needs to put at the root of their domain so then they can opt in to being accessed by Silverlight. That's a security measure. I can answer that later. But that's something that's necessary. It's a security measure. What we're announcing is that in Silverlight 4 beta, if your application is an out-of-browser elevated application, then we no longer check for that policy file. Because as the user presses that install button, they're explicitly giving Silverlight their trust. So we can afford to relax some of the security sandbox. Let's jump to a quick demo of the client HTTP stack. I use the client HTTP stack to pull up that contextual information about every flight when the travel agent clicks on a given flight. That information comes from the Bing version 2 API. The Bing API has a great feature called instant answers. And what that allows you to do is get structured data back from Bing for some common queries, things like flight numbers. So let's go ahead and see how I use the Bing API with the client HTTP stack. Right at the top, you'll see I start with web client, which is the same familiar model from Silverlight 2 and Silverlight 3. I register a base address, and then a completed handler, which will get called whenever Bing returns some data back. This one line here is the important one. You see what I'm doing is I'm associating a URI prefix with this new client HTTP stack. So this is how I tell Silverlight to use the new client HTTP stack for this particular service. That's the one-line change that's needed to switch between the two stacks. The rest of your code remains largely unchanged. Moving down, you see I set some headers on that request. It's a GET request, and I'm setting headers. If you're familiar with the browser HTTP stack, that's not something you can do. That's a feature that only the client stack allows, headers on a GET. And so here I'm making use of the unique REST features of the client stack. This is pretty straightforward. I send my request. I build the query string here. And I'm using the flight name from some data binding from a field in the UI. Here's the completed handler. And you saw I have this rich control that displays nicely data-bound results. So to do the data binding, it's great if I have a CLR type that I can data bind to. So I'm using a feature from Silverlight 2 called the XML serializer. And what that helps me do is take a blob of XML, the blob of XML that Bing returned, and turn it into a CLR type. And that's what this response type actually is. And because it's a CLR type, I can go and basically dot into the type and get to the field I want. I'm setting data context here, and that's how we establish the data binding relationship. Let's go ahead and run this and see how it works. You can ignore this one screen for now. Here's our application. So we select a flight. And the information from Bing basically pops up down here. Go ahead, check out a few different flights. I don't know if you can see that quite well, but if I select a flight that's early, I'm using some fancy data binding down here to actually color some of the UI. I'm a server guy, so this is quite advanced for me. But the power of data binding, right? It's a CLR type. All the UI is defined in XAML. Great, so what we just saw is using the new client HTTP stack to access a public REST service. Now, what happens if we want to build the service ourselves? In that case, what if I have an existing data model, something either in SharePoint or in a database, that's already sitting there, and all I want to do is put a REST head on top of that? The focus being easy data sharing. By using REST, I'm making that data widely available to different kinds of clients on different kinds of platforms. Not just Silverlight. I can access it from the browser, even non.NET clients. The technology of choice to implement this scenario is what we're now calling WCF data services, formerly known as ADO.NET data services. What we're announcing today is that data services is now also being built on top of WCF. And what data services allows you to do is put a REST head on top of an existing data model. Currently, it's a server-side framework for .NET, and there's client-side components that make your life easier from some clients like Silverlight, .NET, Ajax, etc. And SharePoint 2010 is a great example of data services usage. SharePoint stores a lot of structured data. They have lists of tasks, all kinds of stuff. And they needed a way to expose that data in a way that a broad variety of clients would be able to access it. So they chose data services. And SharePoint 2010 ships with a data service built in right there. And that's not the only client API in SharePoint. I'm sure you're familiar. SharePoint has a variety of ways of getting at the data inside of SharePoint. But that's one of the ways that they make available for you. Now, how do you actually talk to this data service from Silverlight? Well, the data service is just a regular REST service. So like we just talked about, we have the client HTTP stack, which is great for REST. So you can go ahead and do that. But we can provide you a better experience in Silverlight because we know a little bit about the protocol that the data services is speaking on the wire. And that's what we call the data services client OM. Because we know about the protocol, the OData protocol, which you've heard about, because we know about the protocol, we can put an abstraction on top of it. So you don't have to worry about things like HTTP or serialization. In addition, it gives you some great features, such as some Silverlight collection types that have a notion of change tracking. So the collection itself will track changes as you make them, and then you can submit back to the server only the things that have changed. It also lets you do things like query your service using a link query instead of trying to guess some HTTP stuff, right? So this is a very nice client-side OM. So enough talking. Let's jump to an actual demo here. I use data services to talk to SharePoint. So in this case, let's assume the travel agents in our agency use SharePoint to collaborate on their tasks. And this is the team site that they all use, and that's where all the tasks are listed. Let's see how we can bring this task list into Silverlight and then modify it. The first thing I did here is I used add service reference. So you go inside your Silverlight control and you use add service reference, and you point it to the built-in SharePoint service. And that generates a local proxy, which is a manifestation of that data services client OM that I mentioned. So you get the proxy, and that's how you talk back to the SharePoint. Let's see. So once I did add service reference, let's see what I did from there. Here's that proxy that got generated for me. And here's that collection type, the one with change tracking. So I can data bind to this type and display it in UI. So here you see I instantiated the proxy. I have a local instance of SharePoint sitting at this port on my machine. And this is the address to the data service that's built in. And it's already at the same well-known, it's always at the same well-known address. So I create my proxy here, I create the collection, and I connect this handler that will get fired whenever the collection gets loaded up with stuff from SharePoint. This update method basically goes out, calls a load method on the collection, and populates it with all the tasks from SharePoint. Pretty straightforward. Here's that load completed handler that just checks for errors. It doesn't do anything really, really sophisticated. Moving down to the bottom here, this is the method that actually adds a new task to SharePoint. You'll notice that I'm actually making changes to this local collection. I'm adding an item to the collection, not directly to the service. So what I can do with data services is kind of batch these changes on my client in this type with change tracking, and then commit all the changes in bulk. So I'm adding this new task here. This method is where I actually go ahead and commit the changes. Now don't be scared by the async pattern. Effectively, we're calling save changes. And when that returns, we're triggering an update of the UI in case some other user made a change to the list as well, so I can bring down the latest entries. Let's go ahead and try this out. Here's my task list. I press this update button and pull down the tasks from SharePoint. So there you go. Now let's go ahead and add a new task. There you go. Let's mark some tasks completed. This looks a lot like Outlook. And let's commit all of our changes. Now to actually verify that this went through, let's go ahead back to SharePoint and check that list. See, I just refresh the page, and the new task that I added pops up right here at the bottom. And then some of the tasks got marked completed. Great. So what we just saw is talking to SharePoint via the data service that it exposes. Now, I've mentioned a couple of times already that we now have WCF, then we have WCF RIA services, and WCF data services. So this slide is to just kind of emphasize the alignment between the different stacks. If you're a WCF developer, you're familiar with the bottom two levels. There's a channel model that takes care of things like formats, transports, and protocols. On top of that, there's a service model level, which it provides you the tools to build a general purpose service description. What we're announcing today is that data services and RIA services are just programming models on top of the existing WCF service model. You can think of them as on-ramps for some specific scenarios that get you off the ground really fast. You want a forms over data app? You choose RIA services. You want something that you want to head on top of an existing data model? You start with a data service. I'm not going to cover this in detail. There was a talk this morning by Henrik Nielsen who actually went through this in detail. So this is where we are. We covered that resource-centric space. We said system.net if you're accessing a public REST service, and then data services if you're building your own RESTful service over an existing data model. So let's jump over to the operation-centric part of the world and see what scenarios live here. We have the app that accesses server business logic, probably via SOAP. We have a chat application, and we also have an application that streams data across an enterprise. So let's dive in and see what technologies to use in these scenarios. And we'll start with request reply and duplex. In request reply and duplex scenarios, WCF remains the technology of choice, and WCF at the service model level, right, from that previous diagram. I know you're all familiar, but let's just rehash again the kind of value prop for WCF. It gives you generated proxies through that add service reference command. It provides you things like serialization, faults. These are all great OM features that make your life easy as a developer. We provide you high performance encoders, We provide you security mechanisms that you don't have to implement manually by yourself. It's already there in the box for you. Now, these features that I just mentioned, they work in both request-reply scenarios and duplex scenarios. But where the value of WCF kicks in really is in these duplex scenarios, we provide you some unique transports that can do both request-reply and duplex. So let's talk about some of these WCF features. I mentioned we have performant encoders. Let's talk about the binary message encoder. The binary message encoder is something that we introduced in Silverlight 3. So if you used Silverlight in version 2, all the messages that were being exchanged between a WCF service and Silverlight were all text-based messages. Now, if you turn on this binary encoder, instead of the messages being encoded in plain text, we switch to this compact binary format. And the benefit of that format is server throughput. If you want your server to scale, the binary format really helps. And here's some data to back that up. What this chart compares is the text encoded, the exact same data encoded in text and then also encoded in binary. So if you're sending a fairly simple message, something like 20 objects in this case, we have a modest increase in peak server throughput, something like 24%. But as you start sending more complex objects, for example, a type with 100 members or an array with 100 things in it, we've measured up to a 71% increase in server throughput. And as the object gets more complex, this gap will continue to widen. You'll start seeing larger and larger gains with the binary encoder. So why does this matter to you? Well, we were just able to serve 71% more clients on the same server box without buying new hardware. That's good news, right? So that's a great feature. Another side effect of the binary encoder is a message size reduction. Now, the reduction will depend on what's the message payload. So if you have an integer type or some really large data, like a large integer, a long string, you're going to witness smaller message size decreases. But if you have a complex object, again, something like an array with many things in it, then you start seeing significant gains from the binary encoder. Now, some of you might say, well, if I just cared for the bandwidth, I would just turn on gzip compression in IIS, and then just, that will give you probably even better savings. The good news is you don't have to choose. You can use a binary encoder and gzip compression in IIS, and you'll get the best of both worlds. You'll get the smallest possible messages, and you'll get the best possible server throughput. So because this is a win-win, the binary format is now the default since Silverlight 3. So if you've used our Silverlight-enabled WCF service template in Visual Studio, you're actually using binary already. One little note that I should make here is that currently Silverlight and .NET clients are the only clients that understand the binary format. So if you're building a WCF service that you want to be interoperable with legacy clients or Java clients, the binary format might not work for you because those clients might not support it. But for scenarios where you're talking .NET to Silverlight or .NET to .NET, the binary encoder just works. Let's talk about some other WCF features. And again, these are both request reply and duplex. If any of you have read the forums around Silverlight 2 and the beginning of Silverlight 3, that first message should be very familiar for you, that first stack trace. This is what 90% of users report when they have a problem with WCF. And what this really tells you is that the WCF faults model is pretty much broken in Silverlight 2. WCF is trying to tell Silverlight what's wrong, but because of some issues, it just couldn't do that. So we fixed that in Silverlight 3. You just switch to the client HTTP stack, and you all of a sudden start getting a lot more descriptive messages coming back from your service. So just by switching to the client stack, and with some changes we made in Silverlight 3, your service becomes instantly more debuggable. Another thing we added in Silverlight 3, and it's also there in SL4, is this new security scenario for cross-domain. Say you're a service developer and you build a service, and you want to have multiple Silverlight clients. In fact, you want it to be publicly accessible. You have to put a permissive policy file at the root of your domain. Now, how do you secure that service? You might be tempted to turn on cookies authentication. and then give the browser a cookie. But what can happen in that scenario is if the browser caches that cookie, the user can then navigate to some malicious Silverlight control, which can then hijack the cookie that it was never given, and then attack your service. This new security mode, which we call transport security with message credentials, puts the credentials in the message, so the browser never gets to see the credentials. The user's credentials are sent by Silverlight to WCF inside every message. And that's why it has to be over a secure transport like HTTPS, because the credentials are now in the message. So the browser never sees the credentials. It can never cache the credentials. So you're safe in these cross-domain scenarios. And now if you think this is not a real thing that can happen to you, well, think again. I think just about 2 weeks ago, Facebook was actually attacked using this exact same approach. They had a very permissive Flash policy file and cookie-based authentication sitting on the same domain. And somebody was able to exploit that. So this is the kind of scenario that this security mechanism is intended to address. So far we talked about features that both work for request reply and duplex. Now let's focus on duplex features. And here's where it gets interesting. To refresh your memory, the duplex scenario is basically the scenario where you need to push some data to the server. Oh, you got new email, or for example, the user is playing a game and they got killed by another user and you need to let them know. This is the scenario for duplex. In Silverlight 4, we have 2 solutions for you to do duplex messaging within WCF. Which scenario depends on whether your client is hosted on the internet or whether it's hosted in your local intranet. If the client is on the internet, then we have firewalls to worry about. So then we have to use an HTTP-based solution to do the duplex messaging. Now, if the client is within the enterprise, we can use a much more performant TCP channel, and we don't have to worry about the firewall blocking that. We offer you both of these solutions. The HTTP-based solution is something that's been around since Silverlight 2, and some of you may be familiar with. It's called polling duplex, but don't let the name trick you. This doesn't just do dumb polling. It doesn't send HTTP requests on a loop. It's actually a little bit smarter than that, and it can save you some bandwidth. It's a lot less chatty on the network level. And if you're interested in exactly how it works, you can catch up with me after the talk. However, this HTTP-based approach has some limitations, and we're aware of that. This has limitations when it comes to performance on the same machine. And so there's basically a natural limit beyond which it's hard to scale this HTTP duplex solution. We're thinking of addressing these problems in Silverlight 4. One thing we're thinking of doing is, currently, the duplex HTTP solution can only send you one message per every HTTP request. What we're considering doing is enabling chunking on the HTTP level. So the duplex service can send you multiple messages over the same connection. And that will help both latency on the client side, and it'll also help scale performance on the server side. That's one new feature that we're considering. Another new feature that we're considering is scalability across machines. There's a limit as to how many HTTP clients you can support on the same machine. So you're going to hit that limit inevitably. And then what happens after that? We're thinking of giving you ways that you can use, that you can still meet your client demand by scaling out across multiple machines. That's not something that's really easy to do in Silverlight 3. And in Silverlight 4, we're considering giving you a way to do that. So you can go ahead and have maybe 5 or 6 or 10 machines running these HTTP duplex services distributed in a fabric like Azure, or even in your own enterprise behind the load balancer. So these are 2 new features that we're considering in Silverlight 4 that are not available in the beta, but you should look out for. Let's talk about the intranet solution, the TCP solution. Because this uses TCP, it's much more performant. I'm presenting this in the context of duplex chat scenarios. However, this works just as well for request reply, and you still get the same performance benefits. So if you have the luxury of having your client and your service both within the enterprise, you can just switch to TCP right away, and you'll help both your server and your client latency. So that's the new TCP We call it NetTCP. That's a WCF term. It's a TCP channel that Silverlight can now also participate in. Now, a word of caution here. NetTCP is built on top of the sockets implementation that exists in Silverlight since Silverlight 2. So it inherits all the same security requirements that sockets has. So you have a restricted port range on the server that you can work with. And also you need to expose a policy responder on that server. These are requirements that are still there. Now the good news is that because of the way WCF is layered, remember we had the channel model at the bottom and then the service model at the top. As a developer, you work on the service model, so you implement your service logic once. The choice of which channel to use is something that can easily be adjusted in an XML file. So you can get the best of both worlds if you'd like. You can easily switch between the HTTP to the TCP transport. You can even use both transports on the same service. So here's some data to kind of underscore the difference between polling duplex and NetTCP. At the bottom, you see the polling duplex data. And one thing to pay attention to here is that the fact that this is a pretty old machine. It has only 2 cores and only 2 gigs of RAM. And it's a 32-bit machine, so don't expect stellar results here. Even then, we have polling duplex scaling anywhere between 500 up to about 3,000 clients, depending on what's the message frequency, so how fast it has to send messages back to the Silverlight clients. And in this scenario, it's sending the same message back to everybody. Now, we didn't do the full set of measurements with TCP, but right away you start seeing that even at the smallest message latencies, so the messages are being sent the fastest, we already get about 4,500 up to 6,000 connected clients at these very short latencies. So the performance benefit of TCP is apparent even right there. So let's put this to the test. Let's go ahead and try NetTCP. The first thing I did is I built my service, and here I'm going to show you the service contract. Now, if you're a WCF developer, this is going to look very familiar. The first contract is the service contract. These are the operations that the client can call. It can subscribe, and it can publish data to other connected clients. It's a chat, after all, right? The second contract is more interesting. This is what we call the callback contract. This is the contract that the service can use to call back the client. And again, don't be put off by the async pattern. Effectively, we have a notify operation, and we pass this notification data message back to the client. The notification data has an author, some content, and a Boolean in there. So this is the shape of my service, and this is the code that I only write once. Now let's see how we configure the transport. I'm going to point to my service web config file. And you'll see down here I configure an endpoint with NetTCP binding. Switching to polling duplex, that's the HTTP binding, is just a matter of changing this one line in your config file. Even better, you can actually add a completely different endpoint here, and the two of them can be sitting side by side. One endpoint talking to your intranet clients via TCP, one endpoint talking to your internet client via HTTP. So you get this duplex scenario working very fast in the enterprise and a little bit slower, but still working from the internet. On the Silverlight client, I started again with my familiar add service reference operation. I point it to the service. It generates a local proxy. This is this chat thing that you see here. And let's see how I actually use that proxy. I instantiate the proxy right here. I don't need to specify the service address. That's already generated for me in a config file. Then I connect some handlers here, and really the only interesting handler is this received handler, notify received handler. This is the handler that will get called when the service tries to send a message back to me. And then I subscribe to messages. This next method, there's some UI stuff in there. The important call is this publish async. This is the method that I use to send a message to all other clients. Here's that notify handler, the one I said is important. This is the one that will get called when the service has a message back for me. And you'll notice I'm working with that notification data type. So it's sending me back, it newed up an instance of notification data, sent it back to me. Here I have access to it in the client, and I can use it for data binding, et cetera. I'm hiding away some of that logic here. So enough talking, let's try this out. I'll open up 2 browser windows so we can chat between the 2. Great, so I have the chat windows here side by side. So let's start typing. And you see, I get character by character chat messages. So I can go ahead and, for example, correct a typo here. And basically, yeah, there you go. You see the messages showing up in the other instance. Of course, this works in both directions. And you see basically the messages appear in both instances. Now, the reason why I can afford to be so chatty, I'm basically sending a message every character, is because I'm using this performant TCP binding. My server can scale without any issue, so I can afford to be sloppy and send every character. Great, so that's the TCP demo. Now, there's this nagging command line thing that keeps popping up every time I run my application. And some of you may have been wondering what the hell this is. Well, remember how I said that this is built on top of sockets, right? And sockets in Silverlight have a security requirement that any socket server needs to be able to opt into being accessed. So by running this one policy server app here, I basically opt in to being accessed by Silverlight clients. Now, it's pretty much boilerplate code all around, but it has to be there. And you can implement it as a Windows service and just leave it running. But it's a little bit repetitive to try to do that every time. So we have a little gift for you guys. If you go ahead and go and try to add a new project here, we use the new online templates feature of Visual Studio to give you this new Silverlight application template, the Silverlight TCP sockets policy server. So you just create this project. It's going to have the TCP server pre-configured for you. You never have to go look it up in the documentation how to write that code ever again. We give you the exact same thing for that client access policy file. That's the HTTP policy file. You basically, it's a new item template, so you will right-click your website and you'll go to item templates and you'll download this one from the internet, and it's the same. You never have to remember what the syntax is. So these are some nice little tools that we give you in VS. Great, so what we just saw is using this very performant new TCP-based transport to do a chat scenario in our app. Now, I talked about request reply. I talked about duplex. Now, all the way on that message pattern scale, we had multicast, which is this massively scalable pattern which uses a network to do the message distribution. What we announced today is that Silverlight 4 Beta now supports UDP multicast. And it's great for scenarios such as streaming any kind of data across many clients. Now, a word of caution here. Because it relies on the network, you have to have a network that's configured correctly to do this multicast feature. And we know for a fact that the multicast groups usually don't scale beyond your enterprise. So this is something that you'll probably end up doing in your local intranet. For example, if we want to stream the PDC keynote to everybody on the Microsoft network, we would use something like multicast. Like I mentioned, scalability is really the big benefit here. Of course, the downside being the fact that the network has to support multicast. The 2 classes you should look out for in Silverlight 4 are the UDP single source multicast and UDP any source multicast client. So you'd use one or the other depending on whether you want to listen to all messages from a given multicast group or just messages from one sender in that multicast group. Now, in the spirit of Silverlight, again, we ask you to expose a policy. As the multicast group gets built, someone on that multicast group needs to allow Silverlight to join. So as Silverlight tries to join a multicast group, it'll send out a message to all connected clients and ask permission before it'll send or receive to that group. And someone on the group needs to reply back to Silverlight and say, yeah, you're cleared to join. And that'll happen based on the domain where the Silverlight control is hosted. So there's this security mechanism. Now, I mentioned that the policy file is basically going away for the HTTP case if you're running an elevated application. We're planning to do the same in the case of sockets and in the case of UDP multicast. So the policy requirements are going to go away if the application is an elevated application. That's not there in the beta, but that's something that we're definitely looking for in Silverlight 4. And with that, let's go back to our original slide here and kind of recap what we just covered. In the operation-centric space, starting at request reply and duplex, WCF is really a technology of choice. It gives you the easiest programming model. Of course, you can use system.net directly, but WCF gives you a nicer programming model for these scenarios. As we push on to multicast, you have to use classes in the system.net namespace to do the multicast pattern. There's no WCF wrapper on top of that. So let's go back to the beginning. These are the scenarios we set out to cover and kind of contextualize within our diagram. We have the forms over data application, and WCF RIA services is really the one-stop shop here. And we have 2 great RIA services talks tomorrow where you can learn all about this stuff. If you want to access a public REST service, we have the new client HTTP stack in the system.net namespace. If you want to build your own REST service on top of a data model, we have data services for you and the nice data services client API. If you want to access server business logic, we have WCF for you. If you want to build a chat type application, again, WCF is the answer. If you want to stream data to the enterprise, we have the new UDP multicast features in the system.net namespace. And with that, I'm going to wrap it up and just point you to some resources. Here's the blogs of all the people that are involved in actually networking and web services in Silverlight. It's not just me. It's actually a couple of teams working together. That last blog there is going to have the code from today's demo. So you can go and download that later and play with it at your own time. My email address is on here. Here are some related sessions that you might find interesting. The sessions today you already missed, unfortunately, but you can go and look at the recordings. The first session is going to talk about WCF data services and where that's going. The second session is great because it will kind of contextualize for you the server-side alignment of WCF, WCF data services, and WCF RIA services. The last session actually shows you some early attempts at scaling polling duplex in Windows Azure, actually built on Silverlight 3. It's not impossible, but it's hard, but these guys have done it. Tomorrow, we have the 2 RIA services sessions by Brad and Dinesh. So these are great sessions that you should all attend. And the last session on there is basically the SharePoint session where you can learn how to use the SharePoint API. We only showed you the data services part of it. There's also other ways to access SharePoint. So with that, I'm going to close it out. Feedback is super important, so please log on to microsoftpdc.com and submit your feedback for the session. I really care for that because it helps me make the talk better afterwards in the next PDC. And don't forget, the charity gets $1 for every eval you submit. All the talks are going to be posted on Channel 9. And with that, I'm going to go ahead and open it up for questions. I'm also going to be available at the Silverlight booth at 4:30. So if you want to stop by, we'll have all the time in the world. I can answer all your questions. Thanks a lot. Thank you. Yeah, could you step up to the mic, please?
Can you run TLS over the net TCP binding?
That's a security mechanism, right?
Yeah, SSL.
So, right. So currently, the net TCP binding that we ported over doesn't support any of the security modes. So it doesn't support security, and it also doesn't support streamed messages. So these are some limitations that we have right now. Yeah, you can do HTTPS over that, yeah. So the question is whether NetTCP will support security after the beta. At this point, we don't really have our plans finalized. I couldn't let you know right now. But I'd be really interested in listening if you have a scenario where you need that. I'd love to hear about it. You have a question?
Yeah, regarding the polling duplex, the version that exists today does not scale at all, like you said. You said in Silverlight 4 they're going to address that issue?
Yeah, so in Silverlight 4, we're looking for ways to scale it in Azure and behind other load balancers. Now, the current version, you're right, out of the box, it doesn't scale. You can make it scale, and that's why I linked to that one talk.
Yeah, we know you have to hack the binding, but...
Exactly. But yeah, in Silverlight 4, we're gonna look to fix that.
Is it maybe, or you are applying
It's
to fix
quite
it?
possibly, yes.
Okay.
I'm sorry. But I'd love to talk to you after, actually, because I'd love to collect people who use polling duplex. Oh, we talked already?
No, we actually did that solution of making it scale.
Are you talking about the service throttling behavior solution to making it scale?
No, there's a post online that explains how the binding...
I'd love to talk to you after, actually.
Yeah,
we can discuss all that.
So that's a big question. You know, polling duplex leads you down this, we can do server push to the clients. But do you think that solution really works in Azure in terms of scale out? I mean, like we have a lot of questions about like how many clients could we get on one instance of Azure, for example? You know, like it seems like with WCF out of the box, it comes with, you know, concurrency single, right? Instance, well, I guess the lifetime single, right? So it kind of comes hobbled, right? Like you're sort of limited right out of the box. You have very low limits at every single one of the bindings, message size, max, you know. And I was wondering if there were any resources or anything on how to really build super high scale WCF, like basically wide open, you know, open your servers wide up.
Yeah, for sure. So I don't know if you heard, there's that talk by Invensys, and they've actually done that. I think they have a prototype where they've actually kind of hacked the server side a little bit, and it actually does scale across Azure. And what we're working on is just that, like you're going to be able to scale it across multiple instances.
Right.
Now, you know, your other question was basically, you know, how many nodes per instance. So I can't tell you that. But
it's very difficult to figure out like how you would tune your bindings and all of that. Yeah,
exactly. No, I'd love to talk to you after, actually.
Yeah, we should talk after.
Thank you.
This may be a naive question, but the transport security, is there a way to get that to work without the HTTPS? And basically, what I want to do is manage the cookies without having to turn on the performance reducing, you know, the impact of yeah.
Right. So if you switch to the client HTTP stack, then you can do the cookie handling yourself. There's a cookie container object model on the request object itself. Right. So the browser doesn't actually see the cookies. You get to manage the cookie yourself. So in that case, you might be able to throw it away when you're done, right, and kind of prevent that particular attack.
Right. And all without the HTTPS.
Without HTTPS in that case,
okay.
Yeah.
Cool.
Thank you. Hi.
I got a really simple little questions.
Sure.
One is, what's the keystroke trick you did to make the code window go full screen?
It's Alt, Shift, and Enter.
Okay, all right. And the other one is, can you put your blog back up?
Oh, for sure, yeah. Sorry about that.
Okay, thank you. Alt, Shift, Enter?
Yeah, go for it.
Hey, how does this smart pooling,
how does the smart polling work? Okay, I think I'll follow up with you at the booth because I need a whiteboard for that. Thank you.
Yeah, actually, I just had one other quick question. Any of the HTTP scenarios, do they support any of the WS star bindings?
So that's a great question. So within WCF, right, we speak SOAP, and SOAP is a standards-based protocol, and WS star is something else, right? So WS star has many things in it. So depending on exactly what you need, you might need a different WS star protocol. So for example, we have support for some of the WS security stuff, like the transport security of message credentials. The headers that we use are actually standard headers that are part of WS security. But then there's many parts of WS security that we don't support. We don't support WS federation. Like there's some stuff we support and some that we don't. So If you have like a really detailed thing, I can try to help you. Yeah, we don't have reliable messaging right now. Yeah, thank you.
I have a Silverlight app that is getting a lot of information from a WCF service.
Is getting, sorry?
It's getting a lot of information from a WCF service,
Yes.
probably 5-6 meg at a time.
Okay.
I haven't found a way to get download status or anything like that using WCF. Using REST, I can get that information, but
That's a good point.
Is there anything? Is anything in Silverlight 4 going to address that?
That's a good point, and we should probably follow up on offline. I don't think we give you, I think we don't have streamed transports in the HTTP or TCP case, so we'll actually buffer up the entire thing before we serve it up to you.
Right.
So yeah, how much we've buffered, I don't think we let you do that, but I need to double check with our devs. Maybe there is a way.
Okay. Okay.
Thank you.
Excellent. Thanks.
Yeah. All right. Thanks, folks.